In this lesson, what we're going to be looking at is some notes from section 3C and 3D, and specifically we're going to be looking at and reviewing the quadratic formula and then some problems related to the discriminant. So this should be a review for you of things that you've done in Algebra 1 and also in Algebra 2. So first of all, let's recall the quadratic formula. So if x is a quadratic equation in this form, ax squared plus bx plus c equals 0, then we can solve for x by just using the formula that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And some of you may have little songs or chants or something like that that you use to remember that formula. So this is just a series of problems that we're going to solve with the quadratic formula, and I've chosen them because they have different types of solutions. And then what that's going to lead into is a discussion of the discriminant and how we can determine the nature of the roots of a quadratic without actually solving it completely. And when we talk about the nature of the roots, we're talking about, are they real? Are they complex or imaginary? Are they distinct? Are they repeated? So that's what we're going to be taking a look at. So these problems 1 through 4 are just sort of a lead into the rest of the lesson. So fairly quickly, and in fact what you might want to do is even turn the video off and try these problems yourself and then turn it back on again and see how you did on them, just as a good review. So for this first one, a is equal to 3, b is equal to 8, c is equal to 4. All right, if you look at the form up here, a is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant. And so that means in this problem, x is going to be equal to negative b, so negative 8, plus or minus the square root of b squared, so 8 squared, minus 4 times a, which is 3, times c, which is 4, all over 2 times a, which is 3. So we end up with negative 8 plus or minus the square root of 64 minus 48, all divided by 6. So that means that this is negative 8 plus or minus the square root of 16, all divided by 6. So this is negative 8 plus or minus 4 divided by 6. So notice what happens with this is that we actually have two solutions embedded in this. So we have the negative 8 plus 4 over 6, and we have the negative 8 minus 4 over 6. So this one turns out to be negative 4 over 6, which is negative 2/3. Or the other solution is negative 8 minus 4 is negative 12, divided by 6, which is negative 2. So notice that there are two, what we would call distinct solutions for that one. Two distinct solutions. The next one, we have a is equal to 5, and b is equal to negative 2, and c is equal to negative 1. And so if we substitute those into the quadratic formula, x turns out to be negative b, but notice b is already negative, so negative negative 2 is 2, plus or minus the square root of b squared, so it's the quantity negative 2 squared. Make sure that you have that negative 2 in parentheses, minus 4 times a, which is 5, times c, which is negative 1, all over 2 times a, which is 2 times 5. So this becomes 2 plus or minus the square root of 4, and then the negative times the negative gives us plus 20, all divided by 10. So this turns out to be, coming up here, 2 plus or minus the square root of 24 divided by 10. And then we should try to simplify that. Notice that square root of 24 can be thought of as the square root of 4 times the square root of 6. So this becomes 2 plus or minus 2 times the square root of 6 divided by 10. And then it turns out that each of those terms can be divided by 2. Or you can think of it as factoring a 2 out of the numerator. So 2 times the quantity 1 plus or minus the square root of 6 divided by 10. I can divide both of those by 2. So I end up with 1 plus or minus the square root of 6 divided by 5. And I want to point out that this also gives us two different solutions. We've got 1 plus the square root of 6 over 5. And then we have 1 minus the square root of 6 over 5. So two distinct solutions. And notice that these are also real numbers. So we can take the square root of 6 within the real number system. For the next one, we have a is equal to 4, and b is equal to negative 4, and c is equal to 1. So that means x is equal to negative b, so again, negative 4 is 4, plus or minus the square root of b squared, so we have negative 4 squared, minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. So we end up with 4 plus or minus the square root of 16 minus 16, all divided by 8. So this turns out to be 4 plus or minus 0, square root of 0, which is just 0 all over 8. So notice that if I try to separate this like I did the one up here, I would have 4 plus 0 over 8, or 4 minus 0 over 8. So that just gives us 4/8, or 1/2, or 1/2. So what I want to point out here with this one is, notice up here again that we had two distinct real roots. I'm going to write that here. Two distinct, meaning different, real roots. Real because we weren't taking square roots of negatives or anything like that. In this one, we also had two distinct real roots. But in this one, notice that what we have is one real repeated root. Okay, and for this one, I'm going to take this down to the bottom. Let's come all the way down here and let's look at this problem 3. So we have 4x squared minus 4x plus 1 equals 0. You actually could solve that by factoring. It factors as 2x minus 1 times 2x minus 1. You can check that with FOIL, equals 0. And then remember how you solve problems like this. This means that 2x minus 1 equals 0, or 2x minus 1 equals 0, which means x equals 1/2, or x equals 1/2, which is what we just got. So notice that it's like we do the other problems where it looks like we're going to get two solutions, but we end up with just one repeated solution. And they are one repeated real solution. They are real numbers. All right, the last one, I really have to squeeze this one in. So for this one, notice that a is equal to 2, b is equal to 1, and c is equal to 1. So for this one, x turns out to be, in fact, I'm going to take this down to the bottom also. So this is number 4. And again, we had a was equal to 2, b was 1, and c was 1. So x is equal to negative b, so negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a times c, all over 2a. So this turns out to be negative 1, plus or minus the square root of 1 minus 8, all over 4. So this is negative 1 plus or minus the square root of negative 7 divided by 4. So now notice in this one that we're trying to take the square root of a negative number, which we can't within the real number system. So we would say on this one that there are no real solutions. Now, in a later section, and I know you've done this already in Algebra 2, that you know how to take the square root of negative 7, that this would really turn into negative 1 plus or minus I times the square root of 7 all over 4. But we'll review that in a later section. So for right now, we'll just say that there's no real solution to this one.